Alright, so in this video we're going to be going over analytic geometry. Alright, so let's go ahead and just jump right in. The first thing we're going to want to talk about is finding the slope of a line. Alright, so for example, if you had the points 2, 1 and 1, 2, and you had a line connecting those points, and we wanted to try to find the slope of the line. First thing, let's just look at it visually so we can see what's actually going on. Because I feel like once you see something, you understand it better. So we're just going to go ahead and plot these points. So 1, 2, 1, and then 1, 2. All right. And if there was a line connecting those points, we want to find the slope of that line. And so the slope is kind of like the steepness. And so what it is, it's the rise over the run, or it is the change in y over the change in x, which is also can be written as y2 minus y1 all over x2 minus x1, where these x and y's are your points over here. So this would be like x1 and y1, and then x2 and y2. All right, so again, you could just plug these numbers into this equation here. But again, let's go ahead and look at it visually. So we just need the rise and the run between these 2 points. So rise, run, and we can just count. So this is going to be 1 and 1. Now because this one here is going down, it's going to be negative, and it's going right to get to this one, so that one's going to be positive. So our rise over run is going to be a negative 1 over 1, which is equal to negative 1, which is going to be our answer. But again, if you don't want to draw all out, you can just plug your points into this equation here. So we can have m equals y2 minus y1 all over x2 minus x1, which is going to be equal to 2 minus 1, from right here, 2 minus 1 all over x2, which is this one here, 1 minus x1, which is 2. And then we're going to get 1 over negative 1, which you'll see is the same thing as we got up here. And that's going to end up being for a total of negative 1 is our slope. So you're going to get the same answer either way, and it's total preference on what you want to do. If you don't want to memorize an equation, it's really easy to just draw something out quickly and to just count them off. All right, so let's go ahead now. If we look at an example like this, I want you to try this one on your own. All right, so 2, 3, and negative 4, 2. So I want you to find the slope of the line that passes through the 2 points given. All right, so find the slope of the line that passes through these 2 points. All right, so you can go ahead and pause this video now and work this out on your own. All right, now that you've tried that on your own, you can find the solution below this video in a PDF. All right, where you can check your answer. All right, so let's go ahead now and talk about graphing lines. All right, so the first thing we want to look at is slope intercept form. Now that's going to be a line given in this form, y equals mx plus b, where m is the slope and b is the y-intercept. And that is where your line crosses the y-axis. All right, so in other words, if we had some line, this point right here is going to be your y-intercept or your b. Okay, and that is going to be the point at which x equals 0, right? Because you're not moving anywhere left or right on the x-axis, you're just going straight up. So you're going to have a point at 0, b. All right? So if we have an example here, if we want to graph y equals 2x plus 1, we can go ahead and start by plotting our y-intercept. So again, we're going to take this value and plot it at 0, b. So that's going to be 0, 1 in this case. So we're just going to come up 1 like that. And then we can use our slope to find another point. So if you remember, our slope is going to be equal to rise over run. So that's going to be equal to 2 over 1. All right, so in this case, we're going to go up 2. Let's see here, we'll extend this line a little bit. 1, 2, and then over 1. All right, now notice because it's positive, I went up and then to the right. And then you can also go down and to the left. Because 2 negatives equal a positive. All right, and then you just connect those lines. And that would be your graph right there. All right, so let's go ahead now and talk about slope of a perpendicular line. So if we had, let's just use the same one for example. So y equals 2x plus 1, and you wanted to find a line, find the equation for a line perpendicular. That's the symbol for perpendicular. Perpendicular to y equals 2x plus 1. And also passes through the point -1, -1. All right. So first we're going to find our perpendicular slope. And that's just going to be equal to -1 over our given slope. So our given slope in our equation is 2. So our perpendicular slope is going to be -1 over 2, or -1/2. All right? And then we can use point slope form to find our equation of the line. So point slope form is going to be y minus y1 equals mx minus x1. All right, where again, x1, y1 is your given point, and m is again your slope. Now in this case, our m is going to be our perpendicular slope that we found, because we're finding that equation for that perpendicular line. So we can go ahead and just plug stuff into this equation now. So y minus a -1, pulled from right here, that's our y1, equals m, which is -1/2, times x minus x1, which we pull from up here, which is a -1. All right, and then we can just simplify this down. So it's going to be y plus 2 equals -1/2 x plus 1. Y plus 2 equals -1/2 minus 1/2. And then y equals, 1/2 x minus 1/2 equals -1/2 x minus 5/2. And that would be your equation for the line that's perpendicular to y equals 2x plus 1 and passes through the point -1, -1. All right, so now I'm going to give you an opportunity to try one on your own. So try. Let's see. What is the equation of the line that passes through the point 2, 4 and is perpendicular to y equals 5x plus 6. All right, so again, just like we did above, find an equation of a line that passes through this point and is perpendicular to this. All right, so go ahead and pause your video now and take some time to work that out. And then you'll find the solution in the PDF below. All right. So let's go ahead now and talk again about, you know what, you can also try this one as well. So go ahead and given the equation y plus 2x equals 10, find the slope, and y intercept. All right, so the first thing you're going to have to do is get it in the form y equals mx plus b, and then you can identify your slope and your y-intercept. So again, pause the video, take a second, and solve that one, and you'll find the solution in the PDF below. All right. So let's go ahead now and talk about finding the x and y intercept. All right, so if we, again, just have some line, all right, where it crosses the y-axis, that's going to be your y-intercept, just like we talked about above. And then where it crosses that x-axis is going to be your x-intercept. All right, and again, notice at this point here, x equals 0, and at this point here, y equals 0. So if we look at an equation, let's say we've got 4x plus 3y equals 12, and we want to find the x and y intercepts. First, let's look at finding our x-intercept. And if we come over here, remember at this point y equals 0, so we're going to go ahead and plug 0 in for y in the equation above. So we're going to start with the original equation, 4x plus 3y equals 12. And then we're going to plug in this 0 for y. So 4x plus 3 times 0 equals 12. So 4x plus 0 equals 12. 4x equals 12. Divide both sides by 4. X equals 3. And that's your x-intercept. So now we can look at finding our y-intercept. And again, at our y-intercept, x equals 0. So we're going to do the same thing that we did for our x, but instead we're going to plug in 0 for x instead of y. So our original equation, 4x plus 3y equals 12. We're going to plug 0 in for x, so 4 times 0 plus 3y equals 12. 0 plus 3y equals 12. 3y equals 12. Divide both sides by 3. Y equals 4. And that's your y-intercept. So this value here would be 4, and this value here would be 3. So this graph is not drawn to this per se. This graph would actually look like this. 1, 2, 3, there's a point there, and then 1, 2, 3, 4, there's a point there. And that would be your equation for that line. And you can also use your x and y intercepts to graph your equations. So now I want you to try this one on your own. You've got the equation 4y minus 6x plus 12 equals 0. And I want you to find the x-intercept and y-intercept. All right. So you can go ahead and pause this video now and try it out, and then you'll find the solution in the PDF below. All right, so let's go ahead and talk a little bit more in depth about our point slope form that we kind of brushed over when we were talking about perpendicular lines. All right, so again, that form is y minus y1 equals mx minus x1, where you're given a point of x1, y1, and m is your slope. All right, so if you're given, let's say, find the equation of a line that passes through the points 1, 1 and 0, 2. All right, so the first thing you're going to do is you're going to want to find your slope. All right, so m equals y2 minus y1 over x2 minus x1. So we're going to have 2 minus 1 over 0 minus 1. So it's going to be 1 over negative 1. So our slope is going to be negative 1. All right, and now we can choose either point to plug into this equation up here, and we'll get the same answer either way. So I'm just going to use that first point. So y minus 1 equals negative 1 times x minus 1. All right, and then you can just use algebra to simplify. So y minus 1 equals, distribute the negative 1, we're going to have negative x plus 1, and then bring the 1 to the other side. So y equals negative x plus 2. All right, so that would be the equation for that line. Now, if you wanted to use your other point, you could do that as well. So you would get y minus 2 equals negative 1, x minus 0. So you get y minus 2 equals negative x, and then y equals negative x plus 2. So again, you're going to get the same answer regardless of what point you put back into your equation. So just pick one that looks nicer to you. All right, so now I'm going to give you an opportunity to try this on your own. So let's see. Write an equation for the line that passes through negative 3, 4 and 2, 2. All right. So again, go ahead and pause this video, try it out, and then you can check your solution. Check your answer with the solution provided. All right, so using what we learned above, if we were given something that said find an equation for a line parallel to y equals negative 3x plus 1 and passes through to 1. All right, so the slope for parallel lines, we draw a couple parallel lines, you can see that their slopes are exactly the same, and it's because they will never intersect. So we can just pull down this slope here. We know that m equals negative 3 for a parallel line, and then we can use our point slope form. So y minus 1 equals negative 3x minus 2. Minus 1 comes from here, and then that 2 comes from there. All right? And then you can just simplify it out. Y minus 1 equals negative 3x plus 6. Y equals negative 3x plus 7. All right, so go ahead and try this one. If you want a line parallel to y equals x minus 2 and passes through 0, 6. All right, go ahead and pause the video and solve that out. All right, so we don't have the solution for this one in the PDF, so I'm going to go ahead and write it out for you right now. So we know that the slope is going to be the same, so m is going to be equal to 1, and then we're going to use our point 0, 6. So y1 in this case is 6 equals m, which is 1, x minus x1, which is 0. So we're going to get y minus 6 equals x, so y equals x plus 6. All right, so that's the solution you should have gotten. All right, now let's go ahead and look at the distance between 2 points. So, for example, if we had 2 points, 4 and 2, and 0 and 1, and we wanted to find the distance between those two, let me just go ahead and show you visually what's going on here. So we're going to just plot our points, 1, 2, 3, 4, up 1, 2, 0, 1. Right, something like that. If I could draw a straight line, it'd be great. Anyway, what we're looking for is this distance here. All right? But what we can do is create a triangle out of these 2 points. All right, and it's a right triangle where our distance makes up our hypotenuse. Okay, so if we can figure out our rise over run, those are going to be the sides of our triangle, and then we can just use the Pythagorean theorem to solve for our hypotenuse, which is our distance. So we can just count on our graph here what our sides are going to be. So this here can be our change in x, which again we can just count as 1, 2, 3, 4. And then this is going to be our change in y, which again we can count as just being 1. Now if you don't want to draw it out, your change in x and your change in y is going to be the same thing that we used in our slope. So it's going to be x2 minus x1, and then y2 minus y1. All right, so if we did that out, we would get x2 is 0, and x1 is 4, so we'd get a negative 4. Y2 is 1, y1 is 2, so we'd get a negative 1. Now, because we're talking about the change, we're talking about distances. Distances are positive, so we're going to take the absolute value of both of these. So this is really going to be 4. This is going to be 1. All right. So now we can remember that the Pythagorean theorem is c squared equals a squared plus b squared, where c is always, always, always your hypotenuse. All right. Always has to be your hypotenuse. So that's the one opposite from your 90-degree angle. All right. So we can just go ahead and plug these values in now. So c is what we're looking for. C squared equals a and b are just either side of the triangle. It doesn't matter which one is a and which one is b as long as they're not the hypotenuse. So 4 squared plus 1 squared. C squared equals 16 plus 1. C squared equals 17. To get rid of that squared on the c, we're going to take the square root of both sides. That'll cancel out, and we'll be left with c equals the square root of 17. And again, c is our distance. So our distance equals the square root of 17. And that's our answer. All right, so go ahead now and try one of these on your own. Let's find the distance between points in 3 dimensions. So let's do 1, 3, 2, and -1, 5, 4. So find distance between the 2 points. So if you'll recall from the 1 and 2 dimensions, we just had our distance equals, we started out with Pythagorean theorem, right? C squared equals a squared plus b squared. All right, where c was our distance. So distance squared equals a squared plus b squared. Now a and b were the sides of our triangles, which if you recall was the change in x and the change in y. All right, so if we add a third dimension to that, we can just add in the change in z squared. All right, so our distance squared is going to equal our change in x squared plus our change in y squared plus our change in z squared. All right. So take a minute and pause this. Try to work it out on your own, and then you can check your answer. All right, let's talk about degrees and radians now. Now, if we wanted to convert back and forth between degrees and radians, if you want to go from degrees to radians, you're going to multiply by pi over 180. Now, if you wanted to go from radians to degrees, you're just going to flip that fraction. So you're going to times by 180 over pi. Now, this conversion factor here is because on our unit circle over at pi, this is also 180 degrees. So pi equals 180 degrees. Now, if you're more comfortable and you can remember it better, you can also use 2 pi and 360 degrees, or anything on your unit circle as long as they equal each other. All right? Now, the reason this works out is we can use a conversion table. So if we wanted to convert 20 degrees to radians, whenever I'm doing unit conversions, I set up this conversion table right here, which is pretty much just one big fraction. So if this was your fraction line, and then these lines here, I'm just separating as being like parentheses. So you could have like 20 degrees over your conversion unit. So pi over 180. All right, so vertical lines are like parentheses, horizontal line is your fraction bar. All right, and so in order to cancel out units, they've got to be on opposite sides of your fraction sign. So I know I'm going to need degrees on the bottom, which leaves radians for the top. And I know there's 180 degrees in pi radians. Again, degrees will cancel. You'll be left with radians, which is what you want. And then you can just multiply everything on top, divide it by everything on the bottom, and you'll get 0.349 radians. Now, if we wanted to go the other way, 0.349 radians, set up your conversion table. Radians is on top here, so we know it's got to be on the bottom, so we can cancel it out. Stick degrees on the top, 180 degrees in pi radians. Radians cancel, and you end up with 20 degrees. All right, so you can go ahead and try one of those on your own. So let's see. Convert 93 degrees to radians, and 1.3464 radians to degrees. All right, go ahead and pause the video now and try that out. And you'll find the solution in the PDF. It's number 7, if you haven't been following along. All right, let's talk now about triangles. And more specifically, let's first talk about similar triangles and what they are. So similar triangles are triangles that are different sizes, but have the same angles. So this angle here is going to be equal to that angle there. This angle here is equal to this angle here. But again, the side lengths are different. And of course your 90-degree angle is going to be the same. All right, so if we had, this is 6, this is 5, and this side is 2, and we wanted to find this side right here, we can use proportions and similar triangles to figure that out. So let's go ahead and just label these. Say this is A for triangle 1 equals 5, B for triangle 1 equals 6, A for triangle 2 equals 2, and we're trying to find B for triangle 2. All right. Now you can set these up in a bunch of different ways. You just have to remember to be consistent with how you're setting it up. So you can have B1 over A1 equals B2 over A2. In this case, you're being consistent with your B's on top, A's on bottom, and then your 1's on one side of the fraction, your 2's on the other. All right, so you got to be consistent horizontally and consistent vertically. So you could also do A1 over B1 equals A2 over B2. All right, so we have got the A's on top, B's on bottom, 1's on this side, 2's on this side. All right, but you could also be consistent with having B1 over B2 equals A1 over A2. In this case, you've got the B's going vertically on one side, the A's going vertically on one side, and horizontally you've got the 1's and then the 2's. All right, which means you could also have B2 over B1 equals A2 over A1, right? So 2's on top, 1's on bottom, B's on left, 1's on right, all right? But what you don't want to do is say have like B2 over B1 equals A1 over B or A2. All right, because you've got your A's and your B's are on different sides, which is good. But on the top here, your crossing numbers, you've got a 2 and a 1, and a 1 and a 2, where you need it to just be one or the other. So you would need to flip one of these fractions. All right, so you don't want to do that. All right, just be consistent, top and bottom, left and right. So let's go ahead now and just solve these. I personally like to just stick one triangle on one side of the equal sign and the other triangle on the other. And then I like to keep my A's on top. So I'll just do A1 over B1 equals A2 over B2. And that's going to be equal to 5 over 6 equals 2 over B2. And from here you can just cross multiply. So we're going to multiply these together and set them equal to those multiplied together. So 5B2 equals 6 times 2. So 5B2 equals 12. Divide both sides by 5. B2 equals 12 fifths. All right, and that would be your answer. So you can go ahead now and try this one on your own. And we're going to be looking at two similar triangles. This side equals 10, this equals 15, and this equals 2, and you're solving for this side x. So find x. All right, so you go ahead and pause the video now, and it'll be number 8 on the solution. All right, let's talk now about the law of cosines. So this one here says that c squared equals a squared plus b squared minus 2ab cosine of angle C. All right, where if we had, some triangle, lowercase letters are sides, so A, B, C. Uppercase letters are angles, and they are across from their corresponding sides. So we've got side A here. Opposite of that is going to be angle A. Opposite of B is going to be angle B, and then angle C. And capital C and lowercase c's are hard to keep track of, so I try to make my capital C's a little bit bolder so I can remember and keep track of them. Now, this equation here can also be rewritten to find different sides. So we can have a squared equals, now since we're doing a squared, these two over here are going to be the other sides that isn't over here. So we're going to have b squared plus c squared minus 2. These letters here correspond with these letters here. So bc cosine, this angle corresponds with its side over on the other side of the equal sign. So this is going to be cosine of A, and then we could have b squared equals a squared plus c squared minus 2ac cosine of angle B. And any of those equations work depending on how your triangle is set up. So let's go ahead and run through an example. If we had a triangle where we know that this angle is 30 degrees, this side is 4, and this side is 5, and we wanted to try to find this side over here. All right, so let's just go ahead and label these. We'll just say this is A, this is B, this is C, which would make this angle C right there. All right, so c squared equals a squared plus b squared minus 2ab cosine of C. So c squared, we're looking for C, 5 squared plus 4 squared minus 2 times 5 times 4 times the cosine of 30 degrees. All right, you stick that all in a calculator to get c squared equals 6.36. Take the square root of both sides. You'll get c equals 2.52. And that would be your answer. All right, so let's go ahead and let you try one of those on your own. If you had, let's see, a triangle where you knew this was 100 degrees, this is length of 5, this is a length of 4, and you're trying to find x. All right. So go ahead and pause the video and solve for x. Now in your solution, this is problem number 9. All right, so let's go ahead now and talk about the law of sines. Now the law of sines says that the sine of angle A over side A equals the sine of angle B over side B, which is equal to the sine of angle C over side C. All right, and you can also reverse those, so flip all of those fractions. You just have to remember to stay consistent like we were doing with similar triangles. So side A over the sine of angle A equals side B over the sine of angle B equals side C over the sine of angle C. All right, so again, keep all your sides on top, all your angles on bottom, or all your sides on the bottom, angle on top, and it won't matter as long as you stay consistent. All right, so if we look at a triangle where we know that this is 15 degrees, this is 30 degrees, and we know that this side equals 5. And we're trying to find this side here. And this side here. All right, so let's go ahead and label these. We'll just say this side's A, this side's B, and this side is C, which would make this angle C, angle A, and angle B. All right, so I'm going to use my law of sines to first solve for A. So I'm going to get the sine of A all over A equals, now the only side that I know is C, so I've got to do the sine of C all over C. All right, so we're going to get sine of 30 all over our unknown equals the sine of 15 all over 5. Now, again, you can cross multiply and solve, and you will get A equals 9.66. Now, once you have that, we can actually solve for our angle B, because the interior angles of a triangle have to equal 180 degrees. So we can do 180 equals A plus B plus C. So 180 equals 30 plus 15, 30 plus B plus 15. And we can solve for B and find that B equals 135 degrees. And then once we have that, then we can use the law of sines to solve for B. So again, we're going to use our sine of C all over C equals sine of B all over B. So sine 15 all over 5 equals sine 135 all over our unknown B. Cross multiply and solve for B, and you're going to get that it equals 13.66. All right. So you can go ahead and try one of these on your own. This is 50 degrees. This is 70 degrees. And this right here is 10. Let's just do find, we'll say this is side A, find A. All right. So go ahead and pause your video now. You'll find your solution as number 10 of the PDF. Now, one thing I want to point out is when you're given a triangle, it's sometimes hard to recognize if you should use the law of cosines or use the law of sines. So let's just point out that the law of cosines is helpful when you know two sides and one angle. And then the law of sines is helpful when you know two angles, but only one side of your triangle, okay? Now there are other times you can use it, but usually it's that time. I'm not going to say all the time, but usually that's the case right there. All right, so okay, let's talk a little bit more about the Pythagorean theorem. We touched on it a little bit when we were talking about distance. Pythagorean theorem. So again, Pythagorean theorem says a squared plus b squared equals c squared. Now, this is only valid for right triangles. All right, so if you don't have a right triangle, don't try to use the Pythagorean theorem because it won't work. All right, so if you've got a right triangle, right, which means it's 90 degrees right there, it makes a right angle. You're gonna have A, B, C. Again, remember C is always the hypotenuse. Otherwise, your equation will not work out. So it's the side squared plus side squared equals hypotenuse squared, okay? And again, it wouldn't matter if I had this side be A or this side be B. It doesn't matter. It's just a side hypotenuse. Hypotenuse is the only one that you got to make sure you stick in the right place. Okay? So if we had this triangle here, said A equals 9 and C equals 15, and we want to find B, you can set up your equation a squared plus b squared equals c squared. So 9 squared, we don't know b, so we're going to keep that as b squared equals 15 squared. So that's going to be 81 plus b squared equals 225. And then b squared equals 144. Bring the 80, subtract 81 from both sides to get 144, and then take the square root of both sides, and you'll get b equals 12. All right, so that's your answer. So you can go ahead and try this one here. If we had that right triangle where this side is 9 and this is 15, find x. So again, pause the video and try this one out. And it's going to be number 11 in the solutions. All right, so let's go ahead now and talk about trig functions. Now this is your SOHCAHTOA. that everyone had to memorize, right? So this is the sine of theta equals opposite over hypotenuse. So sine opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And tangent theta equals opposite over adjacent. So again, cosine theta equals adjacent over hypotenuse. Tangent theta equals opposite over adjacent. Okay, and again, these are only for right triangles. Don't try to use them anywhere else. It won't work. All right. So if we look at this right triangle here, so 90 degrees, and we're looking at this angle here. With respect to that angle, this will be your opposite side, this will be your adjacent side, and this will always be your hypotenuse. But if we're looking at your triangle with respect to this angle, again, your hypotenuse always is the one across from your 90-degree angle, right? So you go straight across into your hypotenuse. But your opposite one is the one across from your angle, so this one becomes the opposite. And your adjacent one is the one that touches the angle that is not your hypotenuse. So that's your adjacent side in this case. So your adjacent and opposite switch depending on which angle you're looking at, but again, your hypotenuse will always stay the same. So if we've got this triangle here, and we know that this angle right there is 30 degrees, and this side is 5. All right, and we want to find A and B. So let's start with finding side A. First thing you want to recognize is that side A is your adjacent side, right? And then we're also given the hypotenuse. So we need the trig function that has the adjacent side and the hypotenuse in it. So you come up here and you're going to see that the cosine is that one. So cosine theta is your angle, 30 degrees equals adjacent, which is our unknown, over hypotenuse, which is 5. Multiply both sides by 5, so you'll get A equals 5 cosine 30 degrees, which equals 4.33. And that's going to be your side A. Now, if we want to find side B, you're going to recognize that B is your opposite side, and we're also given the hypotenuse. So which trig function has the opposite and the hypotenuse in it? It's going to be sine. So sine theta equals opposite over hypotenuse. So sine of 30 equals opposite, which is what we're looking for. So B over hypotenuse, which is 5. Multiply both sides by 5. 5 sine 30 equals B. So B is going to end up equaling 2.5. All right, and that's how you would find side A and side B. Okay, now another thing to remember that's super, super, super important is to check your calculator mode. If it's in radian mode and you're using degrees, you're going to get the wrong answer. So if you're using degrees, make sure it's in degree mode. If at any point you have to switch in and use radians, switch it into radian mode and then switch it back to degree mode. Make sure you're constantly checking this, or at least be self-aware enough that when you get a weird answer that you're probably in the wrong mode. All right, super, super important. So go ahead now and try this one here. This is going to be 70 degrees. This is going to be 4, and I want you to solve for x. All right. Let's go ahead and pause the video. Solve that. Check your answer. It's number 12 in the solution. All right, so just a couple of last things I wanted to talk about before I wrap up this video. Make sure you can find stuff in the reference handbook, okay? There's some other stuff that I didn't go over here and that your quiz doesn't go over that could possibly pop up on your FE exam, but it's more just plug and chug type stuff. So if you can find an equation and then just make sure you know how to use it, you can just plug stuff in there and then get your answer. So things like areas and volumes of conic sections. So 3D objects, so things like spheres, rectangular prisms, pyramids, stuff like that. That's all those equations are given to you in your reference handbook. You just need to know where to find them. Now, if you're taking the computer-based test, you're going to have a digital copy of the reference handbook. So I would suggest practicing with the digital version rather than using a hard copy version. And you do have access to Control F when you're taking that exam, so you can look things up. So if you need to find the area of a sphere, you could type in like Control F and then sphere, and then that would pop up your equation for a sphere. Now, all of these things are found in the mathematics section. But again, just make sure that you'll be able to find stuff in your reference handbook when you get to the test. Be comfortable enough with it. You don't want to be wasting time trying to find something in the reference handbook when you could have done that beforehand, you know? And then another thing to just maybe pay attention to is like the equation for circles and graphing circles, or hyperbolas, or ellipses, things like that might pop up. But again, if you can just reference the handbook and then plug and chug for your solution. So that kind of wraps up our analytic geometry section. So now you are ready to go take the quiz for analytic geometry. My recommendation would be take it until you get 100% on it. All right, just practice until you get 100%. And also keep taking it until you can do it, oh gosh, I would say in probably like 20 to 25 minutes. All right, you want to be able to look at these questions and just know automatically what to do. The faster you can do them, the better, because it'll save you time and give you more time for harder, more complicated concepts. So again, do the quiz till you get 100%, and then also make sure that you're doing it within about 20 to 25 minutes.